Hello everyone and welcome back to our channel. Today, we're diving into an exciting topic in civil and structural engineering, how advanced simulation tools are revolutionizing the field of structural analysis. These tools are not just changing the way we design structures, they're enhancing safety, efficiency, and innovation in ways we couldn't have imagined just a few decades ago. 1. The importance of structural analysis. First, let's briefly discuss why structural analysis is crucial. When engineers design buildings, bridges, or any structure, they must ensure that it can withstand various forces and loads, such as gravity, wind, and seismic activity. Traditional methods of structural analysis often involve simplified calculations and assumptions, which can sometimes lead to suboptimal designs or, worse, structural failures. This is where advanced simulation tools come into play. 2. What are advanced simulation tools? So, what exactly are advanced simulation tools? These tools include software programs that use finite element analysis, computational fluid dynamics, and other numerical methods to create detailed models of structures. By simulating real-world conditions, these tools allow engineers to visualize how a structure will respond to different forces throughout its life cycle. For example, finite element analysis software breaks down a structure into smaller, manageable elements, calculating how each one behaves under various conditions. This level of detail provides insights that traditional methods simply cannot offer. 3. Benefits of advanced simulation. Now, let's talk about the benefits of using these advanced simulation tools in structural analysis. 1. Enhanced accuracy. One of the primary advantages is enhanced accuracy. By taking into account the unique material properties, boundary conditions, and load scenarios, engineers can make better-informed decisions. This leads to designs that are not only safer, but also more efficient in material usage. 2. Cost efficiency. Next is cost efficiency. Although there may be an initial investment in software and training, the long-term savings are significant. With accurate simulations, the need for costly physical prototypes and extensive testing is reduced. Engineers can optimize designs and identify potential issues early in the process, saving both time and money. 3. Improved safety. Moreover, safety is a critical concern in engineering. Advanced simulation tools enable engineers to conduct comprehensive risk assessments and safety evaluations. By simulating extreme conditions, such as earthquakes or heavy winds, engineers can better understand how structures will behave and implement necessary reinforcements or changes before construction begins. 4. Real-world applications. Let's look at some real-world applications. For instance, in the aerospace industry, companies use advanced simulation tools to analyze the structural integrity of aircraft components under various flight conditions. In civil engineering, simulations help design earthquake-resistant buildings in seismic zones, ensuring they can withstand potential disasters. In conclusion, advanced simulation tools are a game-changer in structural analysis. They provide engineers with the ability to create safer, more efficient, and cost-effective designs. As technology continues to evolve, we can expect even more innovative solutions that push the boundaries of what's possible in engineering. Thank you for joining us today. If you found this discussion insightful, please like, share, and subscribe for more content on engineering topics. Until next time, keep innovating and pushing the limits of design. Welcome to Blueprint to Reality. Today, we're tackling a question that seems straight out of a sci-fi movie. Can you really build a house in just 24 hours? It sounds impossible, right? But with advancements in technology, what once seemed like a pipe dream might just be reality. Let's break it down and explore the facts. Traditional construction versus modern technology. Now, when we think about building a house, most of us picture a months-long process of laying foundations, putting up walls, roofing, and installing all the plumbing and electricals. But what if I told you modern technology has completely revolutionized this? We're talking about 3D printing, modular homes, and prefabrication, some of the cutting-edge methods that are making fast builds a possibility. Traditional construction involves a lot of manual labor and material delivery delays, but these modern techniques are changing the game. 3D printed houses. Let's start with one of the most exciting innovations, 3D printed homes. Believe it or not, entire houses are now being printed layer by layer using a large-scale 3D printer. This method eliminates the need for traditional bricks, wood, and steel framing, replacing them with concrete or composite materials. But how fast can it really be? In some cases, companies like Icon and Apis COR have managed to print the walls of a small house in as little as 24 to 48 hours. That's incredible speed when you think about how long it takes to build walls with traditional methods. However, it's important to note that the 24-hour time frame only applies to the structure itself. You'll still need to install the roof, windows, and finish the interior, which can take additional time. Modular homes. Next up, we have modular homes. Think of these as building blocks that are pre-made in a factory, then shipped to your site and assembled like giant Lego pieces. Because the modules are pre-built, the assembly process can take as little as a single day. Yes, that's right, a house assembled in 24 hours. But again, there's a catch. While the assembly is fast, the modules still have to be manufactured ahead of time, which usually takes weeks. So technically, the house can be put together quickly, but the preparation behind the scenes is what makes it possible. Realistic expectations. So, can you really live in a house that was built in 24 hours? The short answer is, it depends. While the structure of a home can be assembled or printed in under a day with these methods, the full completion, adding electrical, plumbing, finishing touches, and inspections, still takes time. These quick builds are great for emergency housing, disaster relief, or those looking for ultra-speedy solutions. But for most of us, the idea of a fully livable, custom home in 24 hours is still just a bit out of reach. That being said, the future is bright. We're closer than ever to rapid construction becoming the new norm, and who knows? In a few years, building your dream home in a single day might be a common reality. If you found this video interesting, don't forget to like, share, and subscribe to Blueprint to Reality, where we break down the biggest ideas in civil engineering and construction. Until next time, stay curious. Thanks for watching. Blueprint to Reality. Today, we're tackling a fascinating question. Can you make a beam stronger by making it hollow? It sounds counterintuitive, but let's dive into the science and debunk this engineering myth. The basics of beam strength. First, let's understand the basics. A beam's strength, or its ability to carry loads, is primarily determined by its material properties and its shape. For beams, strength is often measured by their moment of inertia, which is a geometric property that indicates how the beam will resist bending. Traditionally, solid beams are designed with a specific cross-sectional area to support loads. The more material you have, the stronger the beam should be, right? But what happens if you start removing material and make the beam hollow? The science behind hollow beams. Here's where things get interesting. Hollow beams are often used in engineering and construction for a couple of reasons. 1. Moment of inertia. The moment of inertia, which helps determine the beam's resistance to bending, can actually be increased by making the beam hollow, provided you maintain the right shape. This is because distributing the material further from the center of the beam increases its resistance to bending. A hollow beam with a well-designed cross-section can have a higher moment of inertia compared to a solid beam of the same weight. 2. Material efficiency. By hollowing out a beam, you reduce the amount of material used while maintaining its strength. This not only reduces the weight of the beam, but also the overall cost of materials. The key is to optimize the hollow space and ensure that the beam's shape supports the load effectively. 3. Strength-to-weight ratio. Hollow beams can achieve a better strength-to-weight ratio than solid beams. For instance, I-beams and tubular beams are hollow, but are extremely effective in resisting bending and shear forces. They're designed to be strong and lightweight, making them ideal for applications where reducing weight is crucial. Real-world applications and limitations. Hollow beams are widely used in various applications, such as in bridges, high-rise buildings, and even in aerospace structures. They allow for longer spans and reduce the load on supporting structures. For example, steel and concrete hollow core slabs are common in floor systems because they offer good strength with reduced weight. However, there are limitations. Designing hollow beams requires precise engineering to ensure they can handle the intended loads and stresses. If not designed correctly, hollow beams can be prone to issues like buckling or stress concentrations. Debunking the myth. So, can you make a beam stronger by making it hollow? The answer is yes, but with qualifications. A hollow beam can indeed be stronger in terms of its strength-to-weight ratio and moment of inertia, if designed correctly. The key is in optimizing the design so that the hollow beam performs well under the given loads and stresses. Making a beam hollow doesn't just mean removing material, it's about strategically placing material where it will be most effective in resisting forces. So, while a hollow beam can be stronger in some respects, it requires careful design and engineering to ensure it meets the necessary safety and performance standards. There you have it. Hollow beams can indeed offer impressive strength and efficiency, but it's all about smart design. Thanks for joining us on this myth-busting journey. If you enjoyed this deep dive, don't forget to like, share, and subscribe to Blueprint to Reality for more engineering insights.
See you next time.